Okay, today we're going to finish our discussion of solving trigonometric equations using algebra. So we're going to move past some of the basic equations. And what we have today is something with a radical in it. And basically it says solve sine of u if root 2 over 2. If sine of u equals root 2 over 2 exactly without using a calculator. So that means you need a calculator. So if you're solving something in trig and you can't use a calculator, what do you think you're going to have to use? That's right, your BFF, the one and only unit circle. So we've got our nice little pretty unit circle here so we can reference it. If you don't have one, you need to pull one up on Google or steal one off my desk. Okay, so we know that since we are solving for a variable using sine, we know we're going to have to use the inverse of sine. So if we want to, we can take this with like sine of u equals root 2 over 2, and we can inverse sine on both sides. Oops, sine of -1. And we know that this cancels out, which leaves us with, and we now, if we find their inverse of sine, basically we know where sine is positive root 2 over 2. But we're dealing with the inverse of sine. Remember, we don't deal with anything over here. So sine of root 2 over 2 is right there. So that means u is going to equal pi over 4. So we know that's one solution, but we know since sine has a period of 2 pi, remember we got to take our period into effect. We've got to find the other solution. Because this is the positive side, so we need to go back and find the negative side. Remember from last week's lesson that sine of pi minus x equals sine of x. So all we have to do is plug it in, and we know that the signs on both. We know that we don't have to do this part. We're not going to take the sine of what this is. We're just going to deal with this right here. We already know what x is, or in this case u. So we're just going to do pi minus pi over 4. Now here's where your fraction skills come into effect. We know that since our denominator is 4, we're going to have to use 4 as our denominator. If we do it to the bottom, we do it to the top. So what is 4 pi minus 1 pi? We get 3 pi. And when we subtract fractions, the denominator doesn't change, so we have 3 pi over 4. So we know u is pi over 4 and 3 pi over 4. But we're not done because we know that we have to write our trigonometric equations in a certain form to account for the infinite number of solutions they have. So as we pointed out, we know that sine has a period of 2 pi. So we simply, let's move our unit circle and delete that. Okay, so that means that our solutions are going to be pi over 4 plus 2k pi. And 3 pi over 4 plus 2k pi. So we just solved a trig function algebraically without using a calculator, and those are our two solutions. Okay, and we've got one more example to go with this. Here we have using substitution in basic equations. And now we have solve sine 2 of x equals root 2 over 2 exactly without using a calculator. So again, we know that if we cannot use a calculator, we're going to have to use our good old BFF, the unit circle. The thing is, though, is we've got a double angle identity in there. We've got sine of 2x. So what we're going to do, instead of making this difficult, we're actually going to make it easier. We're going to use our friend called substitution. So what we're going to do is we're going to say, let 2x equal u. Okay, so we know 2x is equal to u. So that means that I can ignore that double angle part right now and just deal with the sine part. So now it's going to look like sine of u equals root 2 over 2. And that's a problem we just got done working. So again, if we're going to have to inverse sine, we know we're looking at quadrants 1 and 4. Sine of root 2 over 2 is when u is pi over 4. So again, we just went into our unit circle and we pulled the value off. The root sine of what is root 2 over 2? Sine of pi over 4. And we know again the other solution, because it's the same process we just did from the same example, that we know that sine of pi minus u equals sine of u. So again, we've got pi minus pi over 4. Get a common denominator of 4, so it's going to be 4 on top and 4 on bottom, because again, the 4s will reduce and give you pi. So we know we've got 3 pi over 4. So we know that u is pi over 4 and 3 pi over 4. So now here's where we're going to have to actually plug it back into our substitution problem. I'm going to get rid of my unit circle because I need some room on the page. So bear with me for a moment. So we've got our solutions, and we know since it's sine, it's got a period of 2 pi. So we've got pi over 4 plus 2k pi. And then we've also got 3 pi over 4 equals, plus 2k pi. But that's what u equals. And u equals what? U actually means 2x. So I'm going to do another nice little form of substitution here. I'm going to plug in 2x, because remember these are equal, so I can substitute interchangeably. Pi over 4 plus 2k pi. Now we still have to get x by itself. So here's the fun part. How do you separate two numbers that are being multiplied together right here? 2 times x. To separate that 2 from x, we're just going to go old school algebra 1 and divide by 2, divide by 2, divide by 2. So that cancels. Pi 4 divided by 2 is pi over 8. The 2's cancel out, so plus k pi. And then on the bottom one, let me make some room. We know that 2x is the same thing as u. So again, we plug that in. We've got 3 pi over 4 plus 2k pi. So again, we have to get x by itself. Divide by 2, divide by 2, divide by 2. 2's cancel. 3 pi over 4 divided by 2 gives us 3 pi over 8. 2 and 2 cancel, plus k pi. So those are our solutions to sine of 2x equals root 2 over 2. So let's recap. First, we substituted, all right? Let me grab it. So first we substituted, all right? Second, we solved the substituted. All right, and so we got u, and now we have to actually go back in and simplify using the substituted value. So we substituted and we solved, and now we have to set original equal to answer, and then we simplified again. Okay, clear as mud, right? I know. But guys, the thing is though, is if you substitute first and you solve it, it makes the solving part a lot easier. And then when you take the original portion of the equation and set it equal to your answer, it was a one-step process. All right, instead of dealing with like double angles, which is no fun. So, and then we simplified, and that just required us to divide by 2, which is something you guys have been doing for about 4 years now. So you've got the skills for this. The substitution I know is a little weird for you. All right, so if you have questions, write them down and get ready to discuss them when we meet again for class.